Good day, sir. I am James Carl Balatero from PSMT2 Betelgeuse. I'm here to explain my answer in CO2 assessment or Sim6 like. So, first is I understood and comply the policy. Here we are. So, first is I copy the cargo table where there is the light ship, the number one hold or the cargo tanks written, and the weight, LCG, BCG, and FCM. So I copy it. Then first is we go to task 1. Task solve the ship's displacement on depth. So ship's displacement on depth is the total weight of the ship including the inside of her. So this is the you just need to add all of it and you will get the displacement so on depth. So displacement on the departure, so the displacement on this departure is 47,008 mt. And let's go to the task 1. So the task 1 is the displacement and the draft. So here we are going to get our final departure, drop, and trim. So here we have a given of 46,947, 47,008, then 47,432. Then in order to get it, we need to solve, subtract, then we get 485, then subtract again, then we get 424. Then here is we have a given drop of 10.60 and 10.70. Subtract, we have the difference of 0.10. So here we're going to solve 0.10 times 424 divided by 485. Then next is we get the multiplication, the answer, the product for 0.10 times 424 is 42.4 divided by 485. We get a result of 0.0874 here, 0.874. So our drop is 10 points. Our given drop is 10.70 subtracted by 0.0874 is equal to 10.613 meters. So we get our forward drop, which is 10.613 meters, and our aft drop is 10.613 meters. Then our mean drop, which is we add the forward drop and the aft drop, then divide it by 2. So we get 10.613. Same, because they have the same aft and drop. So our trim is even kill or 0. So the free surface effect or GGO is equal to the total free surface divided by total weight. So our first is we need to get our the ship's or GOM of depth. So we got our GGO, which is 0.208 mtm by dividing the total free surface effect and the by total weight. So the total free surface effect is 9,791 divided by 47,008. So we get a result of 0.208. So we next is ship's GOM on depth is GM minus GGO. So our GGO is 0.208. So we have a given GM of 3.01, then minus 0.208, that equals GOM on depth is equal to 2.802. Then our GM, well, we get our GM from KM minus KG, 12.61 minus 9.60. Here, 12.61 minus 9.60, we got a GM of 3.01. Then we solve for the GOM. So our GOM is 2.802. Then next is next is the ship's kg. So the ship's kg on departure is equal to the total vertical moment divided by total weight. So our total vertical moment is 451,389.2. 451,389.2 divided by 47,008. So our kg on depth is 9.60 meter. Then our total vertical moment is 451,389.2. Then next is the vertical moment weight times BCG. So this is how you get the vertical moment. So the weight is 8,000.138 times 11.5 light shift, and get a result of 93,587. So that is the vertical moment. Then the longitudinal moment is weight times LCG. So 8,138 times 13.08 is equal to 106,445.04. So our total longitudinal moment is negative 181,480.06. So our ship's LCG on depth is total of longitudinal moment divided by weight. So our longitudinal moment is 181,480.06, and our weight is 47,008. So our LCG on depth is equal to negative 3.886 because it is forward. So here is the all of the longitudinal moment, which are the longitudinal moment is get by weight times LCG. So here in the given table, on this given table, we use the weight and multiply it with the LCG. Here, all of the given multiply by the LCG, we get their longitudinal moment, each of it. And next, once we get all the longitudinal moment here listed here, all the longitudinal moment, and add, then we get 480.06. So that is our total longitudinal moment. Then our vertical moment is equals to the weight times BCG. So still given on the table the weight and the BCG. So this is the weight and this is the BCG. So multiply all the weight to their partner BCG. Then once you get all the vertical moment, then you list it and add all of it, then you get 451,389.2. so that is the total vertical moment. So that is how we get the total vertical moment. Then how we solve for the kg on depth. Next is the task task number 2. Task number 2 is the permeability of the cargo hold is 60%. The bodily sinkage is equal to the weight divided by TPC divided by 100 because it is on cm. So it is, yeah, divided by 100. So we have our weight of 6,918.75 divided by 48.3 close parenthesis divided by 100. So 48.3, and the our weight is the first is we get our volume, our weight. So our weight is equal to loss of buoyancy times density of seawater. So here, how we solve the weight. So first is we solve for the weight, volume of the hole number 2 starboard side. So L, length times breadth and height times height, 25 times 25 times 18 is equal to 11,250. Then loss of buoyancy is 11,250 times 6.60% or 0.60 is equal to 6,750. Then that is our loss of buoyancy. So we can solve our weight now because we have our loss of buoyancy, which is 6,750 times 1.025. Then we get our weight of 6,918.75 mt. So here we can solve for our bodily sinkage. Now we have our weight, so we divided by the TPC, so we get a result of 143.25 divided by 100. So we get our bodily sinkage. Our bodily sinkage is 1.4325. So that is on task 2. So next is the change of trim. So the trimming moment, the MTC times 1 cm divided by 100. So first is we solve for the trimming moment. So our trimming moment is weight times distance of LCF to hold number 2. So first is we solve for the distance of the LCF to hold number 2. So distance is equals to LCG of hold number 2 plus LCF on depth. So we have our negative 38.91 plus 1.05. So we get 39.96. So that is our distance of LCF to hold number 2. So we solve it. Weight times the distance is, the weight is 6,918.75 times 39.96. We get a result of 276,473.25. So that is we're going to use that to solve for the change of trim. So trimming moment divided by MTC, so 276,473.25 divided by 573.2 close parenthesis divided by 100. So we get a result of change of trim is 4.82 meters. Then our change of up, So we solve for the distance from the up to LCF, so we get 85.95. Then the answer for our up is, the change of updraft is 2.38 meters. Then the change of forward drop is 2.44 meters. Then we solve for the departure of drops. Forward, the forward is added by, so the forward, our forward bodily plus bodily sinkage is 12.0455. Then our aft is 12.0455 also. Then we get our change of draft, a change of aft draft. First is, so we subtract it with 2.38, so we get our aft draft. New draft for aft is 9.67 meters. Then our the change of draft for forward is, we add, so we get our new draft for the forward 14.49. Then the mean drop is 12.08 meters. That is, so we have a new trim of 4.82 meters by the head. So the piston stability, so we're just going, so here also, that is all my answer for Sim 6 CO2 assessment. Thank you, sir.